Oregon Hanford Cleanup Board meeting, June 1st, 2026. And would like to remind everyone that the meeting is being recorded. So welcome. We'll start out with roll call and very short introductions of board members and ODO staff. Since we have some new people in the room, I think we'd like to do some very short introductions, everybody all the way around. So take the time to do that during roll call. So Stephen Bedrick. Stephen is the vice chair and he had a conflict today. He hopefully will be joining us shortly. Steve March. And Steve is a former chair and member of this board, so he's been around for quite some time. Allison Jean Cole.
Here.
Would you like to give us a very short bio?
I'm a new member. I volunteer with Oregon Physicians for Social Responsibility. I'm on the board just as a regular citizen member, but the organization has a vested interest in the cleanup. So I report what I learned here to them.
Jim Doherty.
I'm Jim Doherty. Of course, I'm a member of the Oregon Hanford Cleanup Board, your representative on the Hanford Advisory Board and vice chair of the Community Outreach and Engagement.
Thank you, Jim. Mia Burke. She is not present. She's at a meeting in Washington, D.C. this week. Michael Freeman.
I'm Michael Freeman. I'm retired. My educational background is chemistry, so and to chase after chemistry questions. I'm from Hood River, where the state of the Columbia is of great importance.
Sage DeLong.
Sage Long, I'm the emergency manager for Umatilla County.
Esteban Ortiz. Here. Gonna give us a short introduction.
Used to be on the Hanford Advisory Board, now on the Oregon Hanford Cleanup Board.
David Boothroyd.
Here, hi, I'm Dave. I live outside of Portland. I have been on the board for about a year, and I have worked at Hanford, spent most of my career supporting Hanford.
Aaron Ashley. So Aaron is a rep from the Confederated Tribes of Umatilla. He's not present. Tim Seymour. It's on the line. Can he hear us? Tim, are you online? Can you hear us? So Tim is with Oregon Water Resources. Representative Gamba. Everybody online here is okay?
We'll see you in those 2
I hear you just fine.
Okay. Senator Dorsey. Rep Levy.
I am not Rep Levy, but I'm JC Crummel. I'm one of her new staffers, and I'm just here to represent. She had another obligation to leave.
Okay, great, thank you. Rep Tron.
Hi there, everyone. I am Representative Tweet Tran from House District 45, Northeast and Southeast Portland. I apologize for not being there, but I have to wear my uniform this.
Okay, well, thank you for joining us today. And please, please chime in if you have any questions or comments as we go through the agenda. Senator Todd Nash.
Yeah, Todd Nash, home for me is Wallowa County, and Senate District 29 starts just a few miles east of here at the dam and goes all the Snake River. So first time at meetings and newly appointed, so we heard a learning lesson.
Okay, great. And so you're from Enterprise.
Enterprise, yeah.
It's nice over there. And I think that's it. So
Other than staff.
Oregon staff.
I just saw Steve Bedrick join in. Just give
Okay.
Bedrick, our vice chair, a second. Steve, you can hear us. We just say hi.
Hi there, I can hear you guys just fine. Sorry for not being able to be there in person.
Okay, quite all right. Stephen, can you tell us just a very short bio, who you are and,
Oh, yes, I'm vice chair, and in my normal life, I'm faculty at Oregon Health and Science University specializing in machine learning for healthcare applications. So very, always such a pleasure to be on this board, so.
thanks, Stephen.
Yep, thank you very much. Max Woods, Assistant Director at the Oregon Department of Energy for Nuclear Safety and Energy Security. And thanks everybody for being here for our meeting. I'll toss it over to Mark Reese.
Mark Reese, Board Administrator, Staff, Oregon Department of Energy. Hello, Tom.
Hi, Tom Cecilia. I'm the Hanford hydrogeologist. So anything that isn't tank related, that's what I cover for the division.
Matt Hendrickson, radioactive waste remediation specialist. So while Tom covers everything not tanks, I do the tank part.
And I am Sarah Loptang, and I'm an ecologist. After the cleanup, a restoration project will be designed to restore ecosystem services that were lost due to the spills and releases and the cleanup actions. And I work on that.
Okay, we have a few other guests present, so if you guys wouldn't mind very quickly, who are you and where you're from?
Well, I am Jeff Schramm. Hello, everybody. Thanks for having me today. I am with the Environmental Protection Agency, so I'm with the Hanford office over in Richland.
I'm Ryan Miller. I'm the communications manager for Washington Department of Ecology's nuclear waste program, also.
Eddie Holbrook, Deputy Program Manager for Nuclear Waste Program.
Isaac Enstill, I'm the Chief of Staff at State Senator Todd Nash, I'm from Mother Authority.
Okay, thank you. I'm glad you guys from Washington could cross the border and come to Oregon for a change. We will have time for a public comment, open comment at 5:30 this afternoon. First order of business today is to approve the March 2026 meeting summary, which was sent out in the last day or so. And I would remind everyone that the full meeting video is available online, so there's a lot more detail there. The meeting summary is just that, kind of a high-level summary of the topics and discussion. So do we have any comments or changes that anyone would like to see to the summary? Okay, if not, then I think we would approve the March 26th meeting summary without objection. Okay, first order of business on the agenda is U.S. Department of Energy. Who do we have? Wait, Ricky or Tom, who's going to go first?
Good afternoon, Ricky Bang here. Can you all hear me?
Yes, Ricky.
Perfect. And Megan, am I sharing my screen?
Nope, I sent the slides earlier. I guess, forgive me if that's a mistake, but I thought they were sharing them.
We're pulling them up right now.
Perfect.
All right, thanks. Well, I'll go ahead and get started with introductions. And as they pull it up and transition over to slide 2, my name's Ricky Bang. I'm with the Hanford Field Office as the Deputy Assistant Manager for tank waste operations and the waste treatment and immobilization plant. And today I'll be providing an update on our tank waste operations. You know, last session at the Oregon Hanford Cleanup Board, I briefed on the EMF bottoms effort. But today I'll provide a broader update on progress we made with tank waste operations and some of the items of interest to Oregon, I believe. So we'll go on to slide 3. On this slide, provides a very good graphic. I like using this slide to kind of show the progress that we've really made out here especially at the Hanford tank farms. So let me start with what we're trying to achieve here at Hanford, especially with our tank waste mission. We're looking to reduce and remove that environmental risk of tank waste at Hanford. There's tank waste stored in single shell tanks, and those single shell tanks are in farms and groupings that are in the yellow squares throughout the Hanford site. So those yellow squares show you where the tank waste is stored in our single shell tanks. And we retrieve that tank waste that's stored in single shell tanks into our double shell tanks, which are those green squares across this graphic. So when we treat that waste, we retrieve it into double shell tanks. That's one of the previous slide, please. When we retrieve that tank waste into the double shell tanks, that's one of the first steps to reducing the risk here at Hanford. And then when we treat that tank waste, when we solidify it for long-term storage and disposal, that reduces the risk the most. So how are we doing? With Sea Farm, you'll see kind of in the center, those purple dots represents tanks that we have fully retrieved. 16 tanks in Sea Farm have been fully retrieved. That equates to about 2 million gallons and 9 million curies that we've removed from single shell tanks into double shell tanks. And today you'll hear me talk a lot about gallons and curies, because those are two ways to measure that environmental risk that sits in single shell tanks. So again, Sea Farm is fully retrieved, 2 million gallons, 9 million curies. AX Farm was the second farm that we started retrievals. We fully retrieved that tank farm as of last month, this past May. That was official with the retrieval data report that we had submitted. So AX Farm is our second tank farm that we have fully retrieved. That's a significant milestone. Those are 4 tanks out of AX Farm, 1 million gallons, over 2 million curies, pulled from single shell tanks into double shell tanks. We're currently into our third tank farm that we're retrieving. And in that farm, we finished retrievals to the limits of 2 technologies of 2 tanks, A101 and A102. We expect A102 we have finished A102, the 23rd tank in A farm. And we are currently retrieving the 3rd tank that's in A farm. The 24th tank, which you'll see listed in bullets, is A106. So when we finish this 3rd tank, the number 24 tank in A farm, we should do that by this fall. We'll have removed 1 million curies from A farm and from our single shell tanks into our double shell tanks. Currently, we're in the middle of high pressure water sluicing. We just finished up sluicing with Supernate in A106. So we're into our 2nd technology. And that is breaking news. We just started that today. But we're into our 2nd technology in A106 today. It is 92% complete in A106. We're nearing the finish line with A106. We finished the use of Supernate for retrievals of A106 in order to save double shell tank space with single shell tank retrievals. Really since last October 2025, we've really been dealing with a lack of double shell tank space to finish out our retrievals. To kind of give you a sense of the challenge, when we retrieved A101, that first tank in A farm, that stored about 300,000 gallons. The ending volume after retrievals was 1 million gallons, right? So 3x the volume that's stored, we added to our double shell tank system. A102 had 50,000 gallons stored. It resulted in about 200,000 gallons into our double shell tank system, so 4x the volume. A106 had 80,000 gallons stored. We're currently retrieving it. We estimate that it'll need 300,000 gallons, so about a similar 4x in volume with the, once we get and complete A106 retrievals. On this last bullet here on the slide, the number 25 tank that we plan to retrieve is A103. We should start it November 26th of this year. That tank is a large one. It's likely going to need 1.5 million gallons of double shell tank space for us to complete. So one of our largest tanks in order to complete. A lot of salt cake that will end up being dissolved with A103, but we need 1.5 million gallons of double shell tank space to finish A103. And the challenge that we currently have is that there's only 1/3 of that space available today to retrieve A103. Up next, I'll talk more about treatment and solidification and the disposal activities that we're working on to create that space for retrievals. And I'll get more, talk more about the gallons and curies that we're treating there. But I did want to mention also on this slide that once we finish A farm, we'll have retrieved, removed, and transferred to our double shell tanks about 40% of the total curies in single shell tanks to our double shell tanks. Right, so another way to put it, that once that we finish C farm, AX farm, and A farm, that moves 40% of the total curies from single shell tanks to our double shell tanks. 40% of the environmental risk will be moved to our DSTs with our progress in A tank farm. The next 40% of the radioactivity is stored in S, SX, and U farm in the 200 West area, that lower left of the graphic. So another 40% exists in single shell tanks in S, SX, and U tank farms in the 200 West area. Those are the tank farms that we'll retrieve next. That's where we plan to build the processing modules for removing cesium from SY farm. And that's where we'll ship the low-level waste for grouting and ultimately disposal in Utah and Texas. From the 200 West area is where we will go next for retrievals, grouting, and shipment of that low-level waste. We have an upcoming public meeting on June 17th to talk about that new operating unit group in that SY farm. But ultimately, West area operations are still a few years away, 28, 29 timeframe. We'll wrap up design later this year. Permitting should start, well, with the operating unit group, and then the permit application next January, and then operations are the 28, 29 timeframe. We'll move on to the next slide. I'll talk more about the treatment and solidification that we're working on. All right, so with the waste treatment and immobilization plant, we started hot commissioning October of 2025. Through the last 6 to 7 months, we've vitrified, we've made glass out of 115,000 gallons. So it was a great moment for us to cross that 6-figure mark and vitrify over 100,000 gallons. Today, the number is closer to 115,000 gallons. Last month, we vitrified about 30,000 gallons. The month before that was about 20,000 gallons in the month of April. For June, we're currently in the middle of a 2-week outage. So for the month of June, because it's about a 2-week operating period, we hope to see 20 to 30,000 gallons vitrified if things go well with Melter 1 operations when we restart after the outage. July should be a full month, and so we're hoping to get over 50,000 gallons vitrified with the waste treatment plant once we restart. So I did mention earlier the double shell tank space challenge that we have with retrievals. Because of that double shell tank challenge, we have had to pause our tank side cesium removal system since it finished its operations in February. What occurred is that tank side cesium removal system, it treats the tank waste and it puts it into a double shell tank space for storage until it can send it to the WTP. That tank is 130,000 gallons away from being completely full. And when TSCR starts running and operating and processing, it produces 200,000 gallons of pre-treated waste within a batch. So TSCR would run and create 200,000 gallons of pre-treated waste, but today I only have 130,000 gallons of space within TSCR. And that includes really the 115,000 gallons that WTP has vitrified to date, right? So we were tens of thousands of gallons away from being full in AP 106. We've stopped TSCR operations for the last 4 months until we can get enough vitrified to restart TSCR operations, but it still remains paused. We hope to get that space. Based on today's estimate, it sounded like August 2nd. So that would put us at about 5 months of downtime with TSCR. So to put that in a perspective, tank size cesium removal system could treat 100,000 gallons each month. It could remove 30,000 curies each month. So for the 5 months of downtime that we've had, of 500,000 gallons or 150,000 curies is an opportunity that we really missed out on removing that environmental risk from. So, you know, TSCR, again, this is a system that takes radioactivity, radionuclides, and it takes those curies and stores them into stainless steel containers and out of our tank system. We've taken a lot of effort to make as much double shell tank space that we had the last 8 or so months. So to help with TSCR, to help with double shell tank space, we have installed a new glass former powder feed system to the melter feed prep system in the WTP. That should get us a 50% improvement with WTP performance. For context, for 20,000 gallons worth of performance, we should net 30,000 gallons going forward. We revised the 14-day flush requirement to 90 days. You know, that prevents us from adding 2,000 gallons of water every 14 days. With the EMF concentrate, the bottoms effort that we've talked about at the last Oregon Hanford Cleanup Board, we can get a 10 to 20% improvement for WTP. But that really equates to maybe like 10,000 gallons every other month or so, and only up to 87,000 gallons a year. So these are improvements that we've made to get some incremental improvements for future operations. But again, we really need to hit that 1.5 million gallon mark to keep A103 retrievals going next year. So to help also with retrievals, I mentioned before that we've done supernate sluicing with A106. We are trying to do some level rises within some of our double shell tanks to make more space. That may help a little bit, but we'll have to see how we perform through November to see if we've mitigated any of that risk at all. But again, today, the only way we have a way to make space in our AP tank farm is through WTP vitrification in order to get gallons, curies out of our tank system and reduce that environmental risk. And again, just want to point out that TSCR still remains one of the primary ways to remove a lot of those curies out of our tank system. On the next slide, I'll kind of just talk a little bit about EMF bottoms, just as a follow-up to the last OCHB. But EMF bottoms is one of those items that we've been working on with ecology to make more space in order to help with the waste treatment plant optimization and really get that space in our double shell tanks. And I know this is a group of very smart and engaged people, and you will probably know EMF bottoms better than I do right now. So I'll provide a status. Ecology had approved the permit modification on May 26th. We weren't able to get a temporary authorization from Ecology for EMF bottoms. So June 26th will be the soonest that we can ship this EMF concentrate. We do have a subcontract with Energy Solutions in Utah for disposal. Energy Solutions has a contract with Hitman for trucking and transportation, and a contract with Permafix Northwest in Richland, Washington for grouting. So EMF bottoms and concentrate will be grouted before it is shipped. And I know Oregon has made and provided comments about shipping liquids. We've heard you, and that's why I wanted to clearly point out that there is a contract in place to grout in Permafix Richland. It will be shipped by Hitman before it leaves the state of Washington. On the next slide, when we can ship our EMF concentrate, I don't have exact numbers for this, but what it would look like is there would really only be a few trucks going to Permafix Northwest. We can do about 10,000 gallons at a time. So that may be 3 trucks if you do that math. And by the time we get through sampling characterization, you're really looking at, maybe 3 trucks every other month that this would add to the highway system, right? So, and again, the other part is we are limited to just 87,000 gallons a year. We've discussed up to 400,000 gallons with Ecology to help us with that double shell tank space challenge, but we're not successful with that initially. Any changes to the 87,000 gallon volume would require a permit modification. And on this slide, I did want to show that the truck we were using is, I believe, from Hitman themselves. It's a representative photo of the truck, trailer, and container that would be carrying the grouted material from Permafix Northwest in Richland, Washington, to Clive, Utah. I think that's...
Could we ask what form the grouted waste is? Is it in granules, as blocks? And could you describe the physical form of the grouted waste?
Likely just a cementitious material that's filled within that stainless steel container or the steel container. And then it dries and it sort of forms a solid block.
Inside a stainless steel container.
I'll correct myself. It's a steel container. I'll have to confirm if it's stainless.
The container within there.
In my understanding, just speaking from what I know, is as this will be done at Permafix Northwest, they have a process, and the material coming out of that process will be blocks, but they will not be big enough to fill one of these units. So there should be, my understanding, how I envision it, is that there'll be multiple blocks in one of these units.
Okay, go ahead.
Okay. So as we get closer to shipping, we've had some dialogue with DOT, Oregon DOE, and emergency responders about the shipment. And typically what we do is the week of or before the shipment, we provide a courtesy phone call to those interested parties ahead of that shipment. We did that for test bed. That provided a lot of good lessons learned that we'll provide with the EMF concentrate shipment as well. On the next slide, Oh, I did want to at least talk about a dual path concept that we had discussed with ecology. Mentioned several times about how we've been worried about double shell tank space since last October. We discussed EMF concentrator bottoms as an approach, but with ecology, we also discussed a dual path concept in addition to EMF concentrate or bottoms. And I did at least want to explain what that concept is. Because there was a May 22nd ecology letter that alluded to this dual path concept or didn't accurately represent what that dual path concept was. And so to kind of explain what the dual path concept is, let me start with what WTP can do today. And I mentioned it earlier, but on average, we estimate WTP can do about 40,000 gallons a month of tank waste into glass. The last 2 months were 30,000 and 20,000 respectively. Our goals are 30,000 gallons this month and over 50,000 gallons the following month. And we'll continue to ramp up and continue to work on reliable operations from single melter operations. And over the next 2 years and into 2028, we'll fully ramp up to that 170,000 gallons per month or 2 million gallons per year with low activity waste operations and vitrification. Now, what can we do with the upstream systems, the tank size cesium removal system? We can do 100,000 gallons per month. And then once we add 2 additional process modules by 2028, that brings our capacity up to 300,000 gallons per month or 3.6 million gallons a year. And again, there's a delta of 130,000 gallons a month between what we can do with treatment and what we can do with vitrification. Right? WTP has a design rate of 2 million gallons, and we can treat up to 3.6 million gallons with 3 process modules. So really the difference between what we can do with glass and what we can do with treatment is really a missed opportunity to cleaning up that tank waste and reducing that environmental risk. So what is the dual path? The dual path is about getting gallons and curies treated, solidified, and disposed. That concept is to add an alternative treatment pathway to grout and dispose out of state the excess treated waste. Right? That provides operational flexibility in the 200 East area so that we can continue to ramp up WTP vitrification operations. And as it does that, there could be an alternative grout pathway that makes the space needed for both retrievals and continued treatment. Because you have to remember, TSCR is paused today. It's been paused for 4 months. Will be paused for 5. It's 100,000 gallons a month that's not being treated, and 30,000 curies that aren't being removed from our double shell tank system. Those millions of curies that I talked about before, those curies aren't being removed by the TSCR resin and being stored in the stainless steel ion exchange columns. And we have millions of gallons and millions of curies to remove. But currently we have an asset like our tank size cesium removal system that isn't being used 100% of the time. So, we, the department, have been asking ourselves, why aren't we using TSCR 100% of the time? We are, one, absolutely committed to WTP and vitrification. We are feeding it everything it can take. But right now, we can treat more than what WTP can take today. And in 2028, we will still treat more than WTP can vitrify.
Ricky,
and so
Ricky, sorry for the interruption. We've got a question here from Senator Nash.
Sure,
Yes.
thank you. Question that probably everybody in this room knows except for me. What is a Curie?
So Curie is a measure of radioactivity and how much radiation something might release, right? So amount of energy that radionuclides would release. So kind of one way to measure that environmental risk. So it's like measuring how hazardous something might be. For context, for background in Hanford, we have 56 million gallons of tank waste that's stored here at the Hanford site, 56 million gallons. And in that 56 million gallons, there are 100 million curies stored in that tank waste. And our mission is to keep that volume and that hazard out of the tank waste and protect the Columbia River, right? That curie is a measure of the radioactive hazard to the environment.
And I can provide a little bit of Oregon-specific context for radium-226, which is the stuff that makes radon. If it has more than 10 microcuries, it's considered radioactive waste in the state by default. So a curie is like 6 times higher magnitude than a microcurie.
So a general comment, these presentations are loaded with acronyms and jargon. And it's like drinking from a fire hose your first few meetings. And a lot of this really won't make any sense until you actually get out on site and see the stuff that we're talking about. So the August opportunity to go to Hanford and see some of these facilities firsthand is the best way to get up to speed.
Yeah, it's a good question. I really appreciate that. And I am trying my best to avoid acronyms as much as I can. So feel free to pause me anytime I can.
I have a question about the volume expansion factor.
Yes.
That is done before the material goes through TISCR, or is that simply the solids left behind?
So for the capacities that I'm showing on the charts are just actuals without any capacity changes. So this is just the liquid as it moves through the system. So TISCR can do, the tank size season removal system can do 100,000 gallons a month, and the WTP low activity waste facility can only treat about 40% of that.
Yes, but that 100,000 gallon capacity is of niche supernatant or diluted supernatant?
Supernatant.
Okay, thank you.
Ricky,
and
could you?
That 40,000 gallons is the same unit of measure. It's supernate, 40,000 gallons of treated supernate.
Ricky, could you give us a quick overview of what radioisotopes are in this waste and where they end up and which ones are the most hazardous?
Gosh, I say for the tank waste, you almost got the full periodic table in the tank waste. And what we do is, we transfer a lot. Where do I start? So in the shingle cell tanks, right, we really do have a blend mixture of different chemistries in the tank waste. And we also have different types of waste. There's material like sludge material, which tend to be solids, large granules, in some cases, cement in some of these tanks. So we have a sludge type of waste. We have a salt cake type of waste. The tank waste, because of the reprocessing that had been done, contains a lot of salt, sodium hydroxide primarily. And so when it's dry salt ends up being just a salt cake. So it's stored as a dry salt in a lot of our tanks. And then a lot of our double shell tanks have supernate in them. Kind of the liquid fraction, because of the retrievals that we had done, we'll have a supernate fraction, supernate type of waste in our tank waste as well. And so we have a highly caustic tank waste in a supernate form, a salt cake form, and then a sludge form. The supernate form is what we tend to process through our systems in our double shell tanks. And that liquid supernate form is what we then feed into the tank size cesium removal system. And through filtration, we keep a lot of the solids out of it. We kind of do that with selling and decant upstream. Filtration is another way to keep solids material out of the supernate fraction as we feed it to the tank size cesium removal system. Cesium is our primary hazard and contributor to the radioactivity that we have here at Hanford. And so the tank size cesium removal system takes that cesium, puts it onto a resin that's then stored in a stainless steel container. So if you go back 3 slides, just for illustration, I think it was slide this one, you'll see those stainless steel containers in the shipping container. This is the tank size cesium removal system. We have a modular system that's easily deployable, repeatable, reliably removes cesium from our tank waste, and it removes 30,000 curies a month from our tank waste before we vitrify what's left at the WTP law vit. And what we feed forward to the waste treatment plant, low activity waste vitrification facility, is a low activity waste that still contains a range of radionuclides, but we remove the primary contributor, which is cesium, and then strontium as a kind of a sister product. Hopefully that helped answer your question in a couple minutes.
Yeah, so Ricky, somebody that's kind of new to Hanford might be wondering what happened to all the plutonium, the uranium, the iodine, the strontium, the other, high profile bad actors.
Yeah, so a lot of that is stored in our double shell tanks. Much of it is in our sludge material, right? And so as part of our plans, we also have a high level waste facility. That high level waste facility in the midst of design currently. We're doing some weathering in for the high level waste facility, and that will take care of a lot of the high level waste fraction of the tank waste.
Okay.
And I'll get back to this dual path approach, right? So I've talked about how we've presented a dual path approach with glass and grout for what we're treating in our 200 East area, which is adding a alternative pathway, which is grout, to our glass pathway. It provides the operational flexibility for us to keep treatment operations going at that 100 gallons a month and 30,000 curies a month. It allows us to keep retrievals operating and pulling tank waste out of our single shell tanks and into our double shell tanks. And I know Oregon has asked about transportation through their state. I will say we've heard and understand those comments that we've received, but I also hope that you've heard in this briefing and seen what we've are doing with EMF bottoms and concentrate to alleviate some of those concerns and comments. But we do consider those comments as we make our decisions for things like EMF bottoms and grouting in Washington before shipping. So I just want to wrap up this slide. I know I shared a lot of numbers, and I know it's hard to keep track of everything that's going on and all the numbers that I've shared, but there are kind of 2 takeaways that I wanted to provide, is that we do want to clean up Hanford in a safer, better, faster way and not be forced to stop operations, especially when it's within the control of the tri-party agencies, and there is a way to keep that cleanup going. And 2, we still remain committed to meeting all of our regulatory commitments by keeping our facilities, assets, workers progressing cleanup, right? And these ideas are all within our current regulatory framework. So hopefully those 2 points are evident from the progress, the actions and ideas that I've shared today. And I'll pause for any additional questions, and thank you for taking time to listen, and appreciate your time today.
Okay, thank you, Ricky. We have a few questions here, and I want to remind anyone listening in that that this is a board member, so Oregon staff and board members can ask questions. Any other questions will open for public comment at 5:30 this afternoon. So Matt, you have a question.
Ricky, has Permafix indicated to you how much spare capacity they have? Because this idea of the dual pack, 400,000 gallons, I'm not sure they have that capacity without themselves having permit modifications.
Yes, so Matt, they currently have 1.2 million gallons per year for capacity. And really, I think what we're talking about is the low activity waste facility can do 40,000 gallons a month. Tisker, tank size season removal, can do 100,000 gallons per month. And we are just looking to do what we can, right? So whatever the delta is cleanup that's not getting done today. And so if we reach the limit of 1.2 million gallons a year, that would actually be 1.2 million gallons of cleanup that we are doing that we're not doing today. And again, there are other activities going on to explore additional capacity.
Ricky, thanks for the presentation. Couple questions for you. One, is the evaporator currently running? And then the second one is, what's being done to speed up the 2 melter process so you can get that WTP process up so it can match Tisker?
Oh, good questions. Very good question. So the 242 evaporator will do its next operational campaign July 6th, right after 4th of July holiday. It should do one campaign this year, but here's the issue that we run into with the evaporator. It did well over 1 million gallons last year of space that it created, but it's concentrated the waste in AP farm to the point where we can't concentrate it anymore. When you evaporate water from salt water, you get very salty water, and we just can't evaporate any more out of it. And so once we finish this campaign in July, I think that's the only one that we could do this year, because we can't evaporate more water from the tank waste. We have to have an outlet from AP tank farm. And to transition to your second question on WTP melters. So 2 melters exist in the WTP low activity waste facility. We currently can operate 1 melter for a few days at a time. Currently, we're doing better each week. We just had our best run in May to get that 30,000 gallons. We are seeing more melter in leakage than expected, and also higher differential pressures across the system that we're still working through. So today, we don't think we can get to dual melter ops without substantial modification. As we continue to operate 1 melter, we expect to learn more. So we hope not to have a substantial modification, but that's currently where we are with dual melter ops. So we're currently operating 1 melter at a time. We just finished up melter 2 and should restart melter 1 in about 2 weeks.
Thanks, Ricky. This is Max Woods from Department of Energy. This is both a statement, maybe a reminder for all of us, as well as a question. We're 1 month away from the holistic agreement decision point on the west side treatment, disposal, transportation, solidification, et cetera. We hope that DOE is still on target for that July 1st decision point. And as I know that you know, Ricky, we've reiterated a few times, Oregon's position remains, please ship solid waste only through our state with transparency and openness for our people. So and that was really a question more than just a statement.
I understand, Max, and I knew you'd provide that statement. I tried to incorporate it into my briefing, but happy to hear Oregon's position and statement again. And I don't know when we go to questions in the chat, but I think there is one, and so I could answer that one if there's time.
Go ahead. You can.
Well, let's answer board members first. Was that?
Okay.
Yes. Are any board members online have any questions or comments?
Sure, Sage does.
No, online. Online first. Go ahead, Sage.
Ecology's June update says that Congress passed a record $3.35 billion for Hanford. And sorry if I'm reading from my computer. I just want to make sure this is correct. But Ecology estimated a $6.15 billion compliant budget need for 2026. And we understand Hanford has always been underfunded, but now DOE is trying to retrieve more tanks, ramp up vitrification, grout EMF byproduct, consider larger grouting pathways, and manage the double shell tank space, and expand the site-wide permit. And we're preparing these transportation campaign. So my question is, what gets delayed and what gets prioritized, and what risks get carried forward with this budget shortfall?
Nothing. We are on track to meet our regulatory commitments for tank waste treatment, retrievals. We are still ahead of schedule on the high-level waste design that's due in 28. Right, so we have a $3.53 billion budget. We're able to accomplish our regulatory requirements. We are retrieving tank waste as we speak to meet our commitments. West area is ramping up. We'll prepare the designs this year. We'll be able to start retrievals of those tanks to meet our 2040 milestone for West area retrievals. And I think when you think about our dual path approach, the unfortunate reality that we have is that I saved millions of dollars because I didn't operate TSCR. $4 million in material costs not spent because I didn't treat tank waste the last 4 months. I should be operating TSCR so that I can continue to retrieve tank waste. The shipment of tank waste, the grouting of tank waste only helps with that case. EMF bottom saves me 10 to 20% each month, well, up to 87,000 gallons, so I can get more tank waste into glass. Glass powder feed gives me a 50% improvement of tank waste I can put into glass. So we have only done things as a department to continue to be more efficient with how we're approaching the mission.
Hey, Ricky, I think we recognize that and appreciate it. So a few more questions if we could, and let us know if anything here is kind of out of your area of expertise. But we were very happy to see progress moving the cesium strontium capsules to dry storage. Any new update on that area?
I don't, but I know Heather and Scott should be up in a little bit and they can speak to that.
Okay. Likewise, the status of the 324 building?
Same, I'll have to defer to Scott and Heather in a little bit.
Okay. When do we expect them to join us?
They're online now, but I don't know where they are in the agenda, but if there are no questions for me, I can turn it over.
Okay. I guess we got a couple more questions for you, Ricky. Whatever.
Okay, so I'm still just a little bit confused.
I've worked with cleaning heavy materials out of tanks. And I know that it is much more efficient to use fresh water instead of salt water because of the lower viscosity, makes it more efficient. You talked about a 3-time expansion of volume. Where does that excess volume go if it doesn't go through Tisker?
Can you explain your question a little bit more? I did not mention a 3x expansion of volume. I did mention that we are using Supernate for retrievals though.
Yes, you did do that, and that just sparked a memory of trying to wash Bayrite out of bottoms. But in your introductory remarks, my notes say that you discussed a 3 times increase in volume.
Yes, so the resulting retrieve volume, right? And so I also talked about how in our single shell tanks, there are 3 types of waste in our tanks: sludge, salt cake, Supernate. In the single shell tanks, much of it exists as salt cake and sludge. So when we used Supernate to retrieve A106, we use that material to mobilize the sludge. And so we retrieve sludge using that Supernate, and fresh water dissolved a lot of that salt cake. So fresh water dissolved salt cake, we move that into our double shell tanks. We reuse recycled Supernate to mobilize the sludge and move that from the single shell tanks into our double shell tanks. When you dissolve that salt cake and add fresh water, that fresh water is causing that 3x, 4x expansion.
Yes, now I understand.
Thank you.
But now, once that salt cake's dissolved, you regard that in terms of Tisker as Supernate. Is that correct?
Yes.
All right,
That's correct.
thank you. David?
No.
Oh, Jim?
Yeah, Jim Doherty. To kind of piggyback on what Sage was saying, not only ideally we'd have a $6 billion budget, we're looking at 3 and you're working through that, but also the Trump administration is now looking at a 37% reduction. I've got to assume that's going to affect you a little bit. And I don't know if it's fair to say that, by not running Tisker, you're saving $4 million. There's just not the material there to run. It's just delayed spending. And did we anticipate not running Tisker all the while?
No, we want to run Tisker as much as we can, right? Because with just Tisker alone, we would have to be able to feed the WTP, but currently WTP is not keeping up with Tisker. So we planned for WTP at higher rates. We're not there yet, and we hope to run Tisker as much as we can. I can't speak to the 37% reduction, so I won't be able to answer that question. But when you have an asset like Tisker, the tank size season removal system, that we've spent funds on, it's hard to justify not running it 100% of the time.
Okay, Esteban?
Well, don't worry, Senator Nash, I'm on the same boat with you. So as a conflict analyst, I just keep paying attention to the red flags and hope you go more into it. It's like the deer with the headlights waiting for one of these nuclear waste trucks to hit me, right? But you mentioned permits, not full capacity, running out of room. And I think everybody's mentioning, I know right now in a time of budget shortfalls, there's a lot to do. So what's really the status of everything happening and with the work that needs to happen? Because I mean, when I first joined the Hanford board, there was a big thing. It's like I like to see this work done before my child becomes grandpas and grandmas. So when it comes to meeting these timelines, I mean, this is not easy work,
Yes.
So where's the actual timelines and where's everything that's, especially you say with the plant not running at 100%?
Yeah, so we are for the WTP low activity waste vitrification facility. We started it up October of 25 as planned. We are continuing to ramp up. It's its full capability as planned by 2028, right? So those are the plans for the vitrification facility. When it comes to retrievals, we continue to operate to what we had planned. But to your point of why can't we do this quicker, faster, better? And that is the dual path approach that we're trying to present here, is to get that tank waste out of our single shell tanks into double shell tanks faster. We need to have a dual pathway. Get more out of the system so we can continue to retrieve. We are retrieving 24 tanks completed, and that's out of 127 that we have to do. So we have to find as many opportunities to keep cleanup going. So that's what I heard from you, is some frustration that we aren't on a quick timeline to get through our treatment of Hanford. And that was the idea that we provided on this dual pathway, is let's open up a dual pathway in 200 East area so we can do Hanford cleanup quicker, better, faster. We will ramp up WTP operations. Today, again, it's 30,000 gallons a month today, 50,000 gallons a month is our goal by July. And we know what Tisker can do is 100,000 gallons per month. We're going to 3X that in 2 years, in 2028. In West area, we're going to add 2 more modules. So you're going to hit 5 times 1.5, 5 to 6 million gallons a year. Once we get everything up and running, 28, 29 timeframe to tackle the tank waste mission.
Okay. Ricky, excellent presentation. Appreciate that very much. If there aren't any additional questions for Ricky, we can move on to the next DOE presentation. Matt?
Yes.
Jeff, I have a question for you. Would it be possible to get Permafix Northwest to come give us a presentation on their routing process? Have they done that yet?
I've never heard from them at our meetings. We could invite them.
Could we ask them to give us an overview of their process and a very clear understanding of what their final product looks like?
Yes. Okay, yes. I'd ask Eddie for some help, or Ryan for some help with the right people.
Yeah, we can get your point. That's not a problem. Might be able to even get it.
We can take that action.
Thanks, Ricky.
Ricky Bang here, and I can take that action.
Thank you.
Okay, thanks, Ricky.
Hey, Ricky, this is Mark. One other thing that would be helpful, and I do appreciate the photograph of that truck. If you can get some other photos of what it would look like inside the container too, that would also be helpful.
Will do. And I know I do owe a phone call back to James Hall, so I'll do that after this. Thanks.
We appreciate that.
Okay,
All right.
Ricky, who's next?
Heather Dale. So I just want to thank everybody for joining us today. My name is Heather Dale. I'm the assistant manager for River and Plateau. I am essentially responsible for all of the cleanup outside of Ricky's program. Next slide. And so I'll be presenting on the status of our 100K area. The cleanup in this area continues to make visible, measurable progress toward reducing our environmental risk and preparing the K-West reactor for interim safe storage. A major recent milestone was the safe demolition and full removal of the 116 K-West reactor exhaust stack, an essential step in shrinking the legacy industrial footprint near the Columbia River. And this is important because the reactor that I'm going to talk about is the last reactor of the 9 reactors on site that we need to put into interim safe storage. So this will be the focus of my presentation today.
Next slide. Okay. This slide is showing images of the area of our K East and our K West reactors, illustrating where we are in the long-term cleanup and cocooning process of these two reactors. The 100K area housed 2 of Hanford's 9 plutonium reactors, as I mentioned. They were built near the Columbia River to provide cooling water for wartime and Cold War production. K East is already in its long-term, or what we call cocoon state, which is protected within a steel enclosure that was built in 2022. Cleanup attention is now centered on our last reactor, which is the K West, which historically stored over 2,100 metric tons of spent nuclear fuel in its water-filled basin. That fuel was removed safely by 2004, and over 35 cubic meters of radioactive sludge was removed between 2018 and 2022. And these actions represent the removal and stabilization of some of Hanford's highest risk materials. The basin has since been dewatered and grouted. It's further reducing our hazards and preparing the area for full structural demolition. Numerous support buildings, ventilation systems, and utilities around the reactor have already been demolished, further shrinking the industrial footprint near the river. The work that I'll show in the other slides builds on this foundation. Each action, including the demolition of the stack itself, is part of preparing the K West area for ultimately being in the interim safe storage like our K East reactor. And the cocooning, as we call it, is a protective condition lasting about 75 years. The progress demonstrates our steady and deliberate approach to removing risk and meeting our regulatory cleanup commitments. Next slide, please. And then I'll just give an overview of our 100K project. The larger roadmap for completing K West reactor cleanup and preparing it is, like I said, for interim safe storage. This mission includes demolishing approximately 30 facilities and remediating about 50 waste sites. It's a sizable effort that requires synchronized environmental cleanup and structural removal. Demolition of the K West Basin superstructure will continue through FY28, followed by removal of the surrounding reactor structures in FY29. After demolition and soil cleanup around the reactor, our crews will construct the protective enclosure, similar to what is currently on K East, and the reactor will be cocooned. The path to interim safe storage or cocooning is a multi-year engineered progression. It's not just about tearing down buildings, but it's about removing the hazards, stabilizing the structures, and ensuring the environment remains protected throughout these activities. And the demolition activities, including our 116 K West stack work, are integral to our long-term plan. And each step moves us closer to getting this reactor in interim safe storage. For every year that we can pull in this work, we save approximately 20 million in annual surveillance and maintenance costs. So getting this work and progressing it is a priority to the site. Next slide, please. This is a video, and this video shows the demolition of our 175-foot tall K West reactor.
Blowing over it.
The demolition used carefully engineered explosive plans that were executed in an integrated team to ensure the stack fell precisely within a controlled zone to minimize that risk. Bringing down the stack marked a major milestone. It cleared the way for subsequent debris size reduction, below grade removal, and access for demolition of adjacent reactor support structures, which I'll talk about in the next slides. So the next couple slides will be some pictures and I'll walk through them with you. What you're seeing in this picture is crews cutting and breaking the fallen 175-foot stack into manageable pieces. After the 116K West stack was safely brought down, our teams reduced the concrete segments so they could be transported to the Environmental Restoration Disposal Facility, or ERDIF, which is our engineered landfill on site. This is a standard step to ensure our safe and efficient removal of large demolition debris like the stack. This is important because reducing the size of the debris and turning it into a single large hazard into that properly packaged waste that it can be disposed of, clears the work area so that crews can remove the equipment and begin the next phases of building demolition on the east side of the reactor. Finishing the debris removal allows us to continue with east side demolition above grade and allowed for below grade work to progress. And we're currently at approximately 85% complete with that. Next slide. Okay. What you're seeing here is an operator working below grade to load the concrete debris from the stack area into the containers for shipment. The teams removed the below grade portions of the stack and its concrete ducting that connected to the reactor. And they remove all structure and soils down to 3 feet below the building foundation to eliminate any residual pathways. And this is important because below grade removal is essential to long-term protection of the river and to preparing the area for interim safe storage of the reactor with clean boundaries and verified closure of old ventilation pathways. Our controlled excavation, dust suppression, which we'll see in some slides as well, and compliant waste packaging help prevent the spread of contamination and protect our workers during confined space and underground activities. And this is a slide of workers draining fuel oil from the piping that serve the ventilation system's exhaust fans. In this picture, the crews are removing hazardous chemicals from systems so the building can get to demo ready. And completing the last of the hazardous fluid removal eliminates a risk source that lets heavy demolition proceed without the chance of spills of these hazardous materials. And the systematic hazard removal is how we protect our workers and the environment. It's also a required step before we can continue with our demolition activities. This is a slide of our crews using a powered air purifying respirator to safely remove asbestos containing insulation around the former used fuel basin. After we removed the 2.5 million gallons of basin water and treated it at the Effluent Treatment Facility, or ETF, the basin was grouted. Workers started abating the remaining asbestos to prepare them really for basin demolition. This is important because abating asbestos near the reactor and ventilation system prevents dust and fiber release during adjacent demolition activities, which includes work associated with the former exhaust system. And it keeps the demolition zone compliant and safe. And this picture is showing demolition of our administrative areas on the reactor's east side, including work below grade to 3 feet below the foundation. The crews are removing buried rooms and infrastructure such as offices and control spaces that sat near the exhaust system routes. This makes sure that the old buildings and subsurface voids don't remain as potential pathways or obstacles. And just clearing the below grade structures around the stack tie-ins confirms the exhaust system is fully removed and the site is prepared for long-term stabilization, which is what we're currently working toward. And this is a picture of our demolition equipment with shears and hammer attachments using remote controlled water cannons for dust suppression while the 105K West control room comes down. targeted removal of the control room and administrative structures, as I've talked about, on the east side of the reactor, coordinated with continuous dust control, are used to protect our workers and the environment during heavy mechanical demolitions, such as what's going on in the 100K area. Taking down the control room area eliminates structures tied to the former reactor operations, and it clears the area around the old exhaust system, confirming that stack demolition can be closed out with clean boundaries. And last but not least, this is a picture showing the demolition of the supply fan room on the reactor's southwest side, again, using our water-based dust suppression systems. And completing this building allowed crews to enter the rod room. The rod room is where the control rods were handled. The control rods were used to help control the nuclear reaction, and they're actually, the control rods are close to the reactor core. And so entering the rod room and performing air gapping of the fuel rod tubes allows us to continue progress in the west side with the rod rack room above grade. This is important again because we want to remove the ventilation support spaces. We want to verify the air gaps and ensure there's no residual airflow or contamination pathways that are associated with the former exhaust system, so that we can fully retire the stacks function on the site. And together, these steps complete the 116 K West stack demolition, and they move our K West area towards interim safe storage and shrink the legacy footprint near the river and demonstrate careful safety first approach that is expected of us. And with that,
Okay.
I will take your questions.
Yes, thank you, Heather. A couple quick ones. Just for the folks on the board here, all of the waste that's being generated from the demolition is landfilled on site, correct?
Yes.
And people that lived in the neighborhood or downwind might wonder what came out of that stack when it was in operation.
What came out of it when it was in operation?
Yes.
I will have to check on that for you.
Okay, and then finally, where is the sludge from K West now?
Yes.
The T plant.
The sludge from T plant, is that what I heard?
The K West sludge, where is it now and how is it being stored?
I will have to check on that as well.
Okay, any other questions?
I don't want to give you a wrong answer.
I could tell you, this is Ray Geimer, because that was my project when it was going on. So it's stored in the T plant, in the cells in T plant. There's 22, if I think I remember, of these fairly large, heavily shielded storage containers that the sludge is stored in. And it's kept underwater in those containers, and a couple times a year they go in and check to make sure the water level still has the sludge material covered.
So that material ultimately will be treated as high level waste and vitrified?
No, I think its ultimate determination is yet to be made. I believe it's being characterized and handled as potentially transuranic waste at this point.
Yeah, it could be.
But it's basically, it's a lot of it is, it's not high level waste for sure, because it's fuel material that was never subjected to the dissolution process. It never went through, the whole Purex and melting of the fuel and recovery. So by definition, it's not high level waste. That either makes it spent fuel or it makes it transuranic waste.
Okay.
If memory serves, the boilerplate life expectancy of those containers is 40 years. So they've got a little bit of time to make that decision.
Correct.
Heather, what's the schedule, or Ray, what's the schedule for the next steps with the K reactor and the interim safe storage cocooning?
We will
Okay, well-
continue our deactivation activities through FY '28 with potentially, assuming funding goes well with our demolition in '29.
Can we remind the board members, how long that cocooning is expected to last, and the intent of the cocooning itself?
I'm sorry, I missed it.
I really just wanted to clarify for our members, the cocooning lasts, what, 75 years?
75 years from
Yes.
1985.
From
So that
1985.
the nuclear materials can degrade to a safe level so that it can be dismantled.
Yeah, thank you, Heather.
So is there any concern for creating troughs of increased permeability in the places where those cement ducts are removed between the reactor site and the river?
It's a good question. There's a lot of tunnels.
Yeah, I mean, getting rid of the pipe obviously reduces the permeability of the area, but disturbing that soil would seem to me to afford opportunity, a pathway for stuff to make its way down to our Columbia.
So there's a lot of tunnels out there, like cross-site tunnel. And there were tunnels from all at the river up to the water plant. So there were a lot of tunnels out there. So yeah, what is going on with those? Have they been filled in, routed, or collapsed, or? I think that's a good question.
So we're still working on that with our mission partners at CPCco, but we do have a very robust well monitoring network with over 3,000 wells that we monitor and extract samples to see what the flow of contamination is. And so we have a very good water managing the plume and shrinking the plume. So there at this point, I would say that we haven't seen anything that's outside of the ordinary. We're always trying to remove mass and those contaminants from the underground plumes that we have in the Central Plateau.
I'll also point out that with 100K East, when they cocooned it, they put a giant concrete foot around the cocoon. And I'm suspecting that that's going to be the case here too. And concrete is much less permeable than boulders.
So, okay. Thank you, Heather. Appreciate your presentation. I think we have one more DOE presentation. We're running a little bit behind schedule here. Sorry, college. Who's up next?
We have M100 milestones.
No, transportation, sorry. Julia, go ahead if you're here.
Yes, I am. I think you have my slides, but I'll go ahead and get started. I know we're a little bit behind, so I'll try to get things moving. My name is Julia Schenk. I'm the director of the Office of Packaging and Transportation, which is in EM headquarters. We're based out of Germantown, Maryland, and Washington, D.C. We're within EM's Office of Waste and Materials Management. So I really appreciate the invitation to speak today and the interest in our headquarters programs. So changing gears a little bit, but I'm going to talk at a high level about some of the programs and tools that we manage out of headquarters that are available to assist our sites in accomplishing their mission. Ricky hit on a couple really good examples of how some of those things work. So I'll try to make that link as we go along. Okay, so this is our mission. Don't need to spend a lot of time on this. Again, we're a headquarters organization, my office, so we're not on the ground doing the work. That's taking place across the country at our sites like Hanford. So as the second sentence shows here, we provide a suite of programs and tools. So oversight, assistance, policy, software, packaging solutions. As I said, really just a suite of tools that our sites can access to help them get their work done. Our mission is a little bit unique because we are an EM headquarters office, but our programs and policies are available to all of DOE. So that means Office of Science, Office of Nuclear Energy, some NNSA activities. So all that to say that we are trying to maintain consistency across all of the programs in the way that we do packaging and transportation. Next slide, please. So I won't spend a lot of time on this. I just wanted to provide a snapshot of the kind of volume that DOE is transporting in general across the complex. So this is FY25 hazardous material shipments, which is including but not limited to radioactive. We do move other types of hazardous commodities. So we had about 4,900 hazmat shipments in FY25. That's very consistent with what we see year over year, which is about 5,000 shipments. In the breakout here, you can see that EM had just over a third of those shipments. Again, not all of them were radioactive, but when we're talking hazardous materials, these still require special care and attention as far as safety and regulatory compliance. So most of the programs that I'll talk about throughout the presentation apply not only to our radioactive material shipments, but to anything hazardous that we're putting on the road in the public domain. Next slide, please. So this is EM waste specifically. You can see in the chart, which probably is not a big surprise, the majority of EM's recent waste shipments are spread across low-level waste, mixed low-level waste, and transuranic waste. The other category could include other RCRA waste that's non-rad, used fuel, other special materials. Next slide, please. So there's a lot of information here. I'll try to cover it quickly. So we're moving 5,000 shipments a year. What are we, DOE, doing to ensure that these shipments are moving safely and in compliance with regulatory requirements? And how do these programs and tools help enable the mission at Hanford and DOE sites around the country? So the first one I'll highlight here and get into a little more detail later on. Under compliance, we have our motor carrier evaluation program. At any given time, we have about 30 carriers that we specially evaluate and approve to transport radioactive and hazardous materials for the department. So as a baseline, if we're putting something in the public domain, offsite, on the roads, we're complying with Department of Transportation. Everything here is DOE specific. Programs and tools that provide additional safety, security, communications measures that are specific to DOE shipments. So one of those is our carrier evaluation program. Ricky mentioned in one of his slides, the contract with Hitman in conjunction with the work being done at Permafix. Hitman is one of our approved carriers. Again, I'll talk about that a little bit later. We also have a team that goes out to DOE sites to assess packaging and transportation activities and provide assistance to sites as needed. We have a packaging certification program. It is equivalent to the Nuclear Regulatory Commission, NRC's program for certifying Type B packaging specifically. Of course, what we certify out of my office only applies to DOE. Those approvals can only be used for DOE shipments. We also do a lot of work as far as training and sponsoring courses in packaging and transportation, which has become really important, especially with attrition and knowledge management across the complex and in the nuclear industry in general. Partner engagement and training. I think these two programs will probably be of interest to the group today, so I'll get to those in a moment. One is our Transportation Emergency Preparedness Program. So this is a program that my office sponsors for first responder readiness and training. Planning, tools, hands-on classroom training, and that's offered at no cost to jurisdictions along shipping routes. So I'll get to that and some statistics in a little bit. The National Transportation Stakeholders Forum, I'll get to that as well. So we have relationships, grant agreements with state regional groups, so West, Midwest, East, and South, as well as the Tribal Radioactive Materials Transportation Committee, which represents about 20 tribal governments. So we engage with them regularly, and we actually have an annual meeting coming up in just a few weeks. Software, won't spend a lot of time here, but again, these are tools that we make available to sites to help them facilitate the work that they have to do. One is transportation routing. So this is kind of a way to overlay shipping routes and see proximity to first response capabilities, hospitals, populations, things like that. So that's just one example of the tools that we have available. Field support, that's really most of what we do is work with sites around the country. How can we help? How can we make sure that we're doing things safely and securely when we put materials on the road? Policy and regulatory support. So we do have, as I mentioned, DOE specific requirements that in many cases go above and beyond Department of Transportation baselines and 49 CFR. So we manage those. Ricky also touched on that a little bit. So best practices as well as regulatory requirements. So the orders require a couple items, as I mentioned, above and beyond. So the motor carrier qualifications, that is a DOE regulatory requirement that for certain types of rad and hazardous materials, these specially qualified carriers have to be used. We also have requirements for engaging with state and tribal governments, sharing transportation plans, advanced shipment notifications, escorts and inspections for certain types of shipments, things like that. And those are generally related to higher risk or higher volume shipping campaigns. But Ricky mentioned in many cases, these are just best practices, like we found out during the test bid initiative and other campaigns. Next slide, please. So again, this is our motor carrier evaluation program. It seems that this program has been of interest, particularly to our partners. So again, Department of Transportation has baseline qualifications. Hazardous materials trucking companies have to be qualified by Department of Transportation. They have to hold the appropriate qualifications. We take that a step further for our Department of Energy carriers. So we've modeled a lot of our program on how Department of Transportation conducts inspections. But there are hundreds of hazardous materials carriers approved by DOT. We have DOE specific requirements that are included, and we're doing it for our 30 or so carriers. Obviously, Department of Transportation can't get out and inspect every single hazardous materials trucking company in the country. That would be impossible, but with Department of Energy, we do. So we do a full evaluation when a trucking company joins our program, and we follow up with another full evaluation every 3 years. In the interim periods, we're constantly monitoring carrier performance. We have a close working relationship with Department of Transportation, FMCSA, which is the Federal Motor Carrier Safety Administration. And we also have access to their system for carrier safety reporting. So even if something were to happen with one of our trucking companies not related to a DOE shipment, we would have visibility of that information, such as accidents or inspections. Next slide, please. So again, this is our NTSF program. So this is chaired by EM, by the Office of Packaging and Transportation, but we also have a partnership with the Office of Nuclear Energy within DOE. And we have participation from other federal agencies, so Department of Transportation, Nuclear Regulatory Commission, and of course, I mentioned our state and tribal partners. So this is one of the primary ways that we communicate at a headquarters level with those partners. So we collect and share input on planning for shipments, for campaigns. When we revised our DOE-specific order, we coordinated that revision with our state and tribal partners before we released that and finalized it. We have an annual meeting coming up in the summer, usually about 200 attendees from local, state, tribal governments, other federal agencies. Very strong participation from first responders and emergency response planning and management agencies across the country. We also do public webinars on various technical topics throughout the year. And we have semi-annual meetings with all of our partners as well. I believe, yes, the website link is here. It's public. Most of our webinars are either recorded or the slides are posted. If you see anything that might be of interest. Next slide, please. So one of my favorite programs to talk to, very important to the department, and I think and I hope to our local partners as well. So our TEP program is best known for training classes on radioactive materials emergency response, the primary course being MERT. These are in-person classroom courses with hands-on activities and equipment, actual sources, taught by DOE instructors. And again, this is no cost to jurisdictions along shipping routes. So primarily we're training fire departments, but we've also done training for police departments, hospitals, etc. We also have a train the trainer course so that state and local emergency planning departments can deliver that course content to broader audiences if they wish, outside of DOE shipments. So in FY25, we trained over 2,000 first responders in over 100 classes. And that was kind of a record year, but we usually tend to be pretty close to those numbers. I believe, let me look at the dates. Just a couple weeks ago, we held our training course in Hermiston. That was May 14th and 15th, and we had about 20 first responders who participated in that training. So again, the website information is here. We have regional coordinators. Their contact information is on that website, tepinfo.com. And they, as well as myself and the rest of my office, were very happy to provide more information, reach out, see if there are training needs that might be of interest to Oregon and to your local partners and stakeholders, emergency responders. It's a program that we really have invested a lot of resources into. So happy to talk about that more or answer any questions.
Thank you very much for your presentation. We're running way behind schedule, so I would like to maybe take 2 questions now, if we could.
Yes. Just the quick question, and I don't know, but in the Columbia Gorge, I found out, I guess, that I guess they sealed off 84, and a lot of people have been asking about, like I said, train the trainers, how would it be all the way possible? I don't know if there's shipments going on, all that about having people train, especially like, I don't know, fire marshal who gets trained.
I was gonna get to it later in the update, but we just completed, as Julia mentioned, we just did a TEP course in Umatilla County. Dr. Steve Reese and I from Oregon State University were just out on the corridor doing training in Ontario and also Baker City. What do you mean by shutting off the corridor?
Well, they were saying, I guess, what fires, I don't know, but like when there's an emergency on 84 there, I'm like,
oh, when it be no truck traffic or anything.
Yeah, no truck traffic.
Yeah, yeah. But that would be up to, if you had an emergency manager, like just use Sage, if he had anything in junction on 84, they needed to close down 84, then nothing would be done, including these shipments.
So do we have any other questions specifically for Julie?
Yeah, Julie, Sage here. Just a clarification, is it your training and kind of the standards, is this largely dependent on the classification of the waste that's being transported?
So the training that we provide is not necessarily even specific to waste. It covers a range of radioactive materials. So yes, well, no, the training is not commodity specific as far as any particular waste stream. It is specific to Class 7 radioactive materials.
Yeah, and then so the follow-up with that, so with, you know, aside from the training with inspections and notifications, that process, is that dependent on, you know, the level of waste, low level waste versus high level waste? I'm assuming there would be a different process of notification.
Yes, you are absolutely correct. And we do have requirements that are specified in the DOE orders that I had in a previous slide. So there are very specific requirements for things like high level waste, use nuclear fuel. And we have, this kind of goes hand in hand with our TEP program. My office also maintains a couple different contact lists. One is a contact list for state and tribal government representatives who receive advance shipping notifications for those certain waste campaigns that rise to that level. The second list is state and tribal 24/7 emergency contacts. As far as emergency response. So I think that kind of gets to the previous comments about, well, what happens if a route shut down and things are going somewhere they wouldn't usually go? One of the ways that we help our sites is by maintaining that list of state contacts.
Okay, Julie, thank you very much for your presentation. Feel free to hang around because some of these issues will resurface later today in the Oregon Department of Energy's presentation on true waste. So feel free to stick around. So we're going to move on now to ecology, Washington Department of Ecology. So please. Great. That's all right.
All right, well, I appreciate everybody's time and I'll try to move through this as quickly as possible to respect everybody's time here. I think we're gonna get started here. So my name's Eddie Holbrook. I'm the Deputy Program Manager for the Nuclear Waste Program with Department of Ecology, and one of our main focuses at the Nuclear Waste Program is the Hanford site. I can move on to the next slide. So a little bit of what we're going to talk about today is just give an update on the outreach and education that we're doing through the Department of Ecology. Talk a little bit about the Hanford budget updates, projects updates, public involvement activities and opportunities that are coming up, as well as the Hanford site-wide permit renewal. All right, so Ryan and his crew have been awfully busy in the month of March, and beyond that, reaching out to over 2,400 people and conducting activities at 21 events in the last month or so. Some upcoming events that folks might be interested in. So Ecology Night at the ballpark in Tri-Cities at the Dust Devils game. I think it's more of an agency-wide activity, but NWP is going to show up and participate in that as well as environment activities with B5 Learning Center. Next slide. So some folks had some questions about the Hanford site-wide budget and what's being proposed right now. So Congress did pass the record number of $3.35 billion for the Hanford site for FY26. Unfortunately, the current proposal that's out there right now is about $400 million less than FY26 for FY27. Ecology continues to monitor the budget process associated with this with Congress, and we'll continue to update that. What you're seeing here from this graphic comes off of our one pager. So every year we put out a one pager that talks about what is the money that Department of Energy needs to meet all its obligations under the tri-party agreement and court orders and under the permit. And you're seeing that number here being analyzed from the life cycle report that we look at every year and match that up with what's being proposed. And as you can see, year in, year out, Hanford is underfunded to meet its basic obligations out at the Hanford site over and over again. So we continue to advocate for that compliant budget number to meet all those obligations to clean up the Hanford site as quickly as possible and meet all those milestones that are currently on the books right now. Next slide. All right, a little bit about the M100 milestone series. So I know there's been a lot of engagement with the Oregon Hanford Cleanup Board associated with this. This process is wrapping up right now. So we had the public comment period, the public meetings associated with this. We're going through the final steps of finalizing this. And specifically, I just wanted to point out that there have been some minor changes associated with the public comments received associated with that. So the feedback was well received and utilized as we kind of finished up the package for the M100 series, which includes the compiling of N15 related to covers and remedial investigations, feasibility study investigations, the process of for all non-tank farm, non-canyon related operating units, M16 milestone series, and the M85 milestone series as well. So next slide we have here is, you heard a lot of it from Ricky, so I won't reiterate it, but ecology is continually encouraged by the work that's happening at direct feed low activity waste. You heard a lot from Ricky about where we're at today with this facility and what's going to be treated over the next couple of months. We've reached 100,000 gallons, and we've moved past that in the last week or so to 115,000 gallons. And we continue to want to see Department of Energy ramp this up to meet its current obligations. So we heard a little bit of from, I believe, Esteban over here about how are we getting up to these, what are the milestones associated with this, specifically with meeting their obligations. So direct feed low activity waste has a 3-year runtime to get up to a 70% efficiency optimization of the plants. They have to reach 21 metric tons per year. Right now, the Department of Energy is learning the personality of the direct feed low activity waste plants, working through some of the kinks. Most recently, one of the kinks that Ricky had talked about was switching from that slurry of glass forming material to the dry powder, which gained that 50% efficiency that Ricky had talked about. Some other efficiencies that have been gained with partnership with Department of Ecology have been the modification that was recently just closed out here, where we issued the EMF bottoms, which could increase the efficiency of direct feed low activity waste by 20%. So we're looking forward to seeing these things kind of play out right now, right? So the switching from the wet material to the dry powder for the glass forming material had just recently happened within the last couple of weeks here. So we want to see those efficiencies play out in the actual runtime of direct feed low activity waste. And when it comes to the EMF bottoms, so we just issued that letter just not too long ago. And go ahead.
Interrupt you for a second. Could you go back one slide, please? Is it possible to zoom in on that picture in the lower right? No. So if you could describe that, because that's an amazing picture that shows the scale of the landfill and this operation. If you could describe that, it's just.
Yeah, definitely. We have some folks out there being pleased. So going to that in particular, right? So coming off of what's been put into glass up till now, there are 82 containers that have been filled at this point. That is being disposed of on the Hanford site. There is a landfill called the Integrated Disposal Facility on the Hanford site. Is permitted by Ecology, and it is fully operational today. And what you see there in that very small picture is the first canister being placed into the landfill at this time. The whole purpose of this landfill is to support direct feed low activity waste. It will be the final disposal place for all those vitrified tank waste canisters. And it will also support some of the secondary waste that will be created by direct dimensions of that cell by chance. What's that? The dimensions of that cell. I do not have the dimensions of the cell off the top of the head. Canisters 6 to 8 feet tall, correct? Correct. Yeah, so everybody kind of get an idea of how big that cell is where that one canister is going.
It's a lot.
So one plug in for something that recently was put out by Ecology. So we do have these things called baseball cards, which are one pagers for each one of the facilities on the Hanford site. And we do have a baseball card for the integrated disposal facility. And it should have information about like how big those cells are, some information about it. We might be able to update it if we need
That
to.
would-
So
Yeah, it's just a
So,
scale
quick
like
clar-
1,500 feet wide,
While we're paused.
65 feet long.
Eddie, you mentioned 21
45
metric
feet.
tons as a milestone. We were hearing a lot about gallons. So where do we convert metric tons to gallons here?
Yeah, so tough question. Just off the top of my head about converting, the two, I think it's, Ricky had mentioned, DFLAW has to get up to like 2 million gallons per year of, treated waste, right? So that would equate to 21 metric tons per day that has to be produced, in the 3-year period. So from October 15th, when DFLAW started, Energy has 3 years to optimize this facility and get it up to 21 metric tons per day.
So we've probably done 1 metric ton in those 82 canisters, if it's about 100,000 gallons per metric ton.
It's probably much more than that. I would not be able to answer that question.
Sorry to put you on the spot.
So just to restate it, that 21 metric ton
Yes.
can't translate directly to the tons of waste in the tanks because there's an extra dilution factor involved.
So I can create an answer. It's Ray again. So if you're talking about what we're averaging is about 250 gallons per hour currently. So that would be about 6,000 gallons in a day would make that 21 metric tons of glass. And that number could go up depending if they could get a higher production rate than the 250 gallons an hour, which they've gotten as high as 280 in an isolated case. Does that make sense?
That's a little bit better context.
Yeah,
Thank you.
Thanks. So Allison, you've got a question or do you want to?
I have one thing. If somebody asked questions about the dimensions of IDIF, my team has provided. Each of the 2 disposal cells is 205 meters wide, 219 meters long, and 12.8 meters deep. Very big.
Very large.
Allison?
You mentioned a few other types of things that will go in here besides the vitrified waste. Is grouted waste allowed in IDF?
So there is a process of secondary effluent that goes to the effluent management
That's the
facility.
EMF.
Yeah.
Yeah.
So not the EMF bottoms themselves, but there's an evaporator in the effluent management facility that separates off the heavy materials, which become the bottoms, and then the lighter materials that get transferred to the effluent retention facility, the liquid effluent retention facility, which is a facility that's already on site. And it gets transferred into the effluent treatment facility for further treatment. That is the brine from the effluent treatment facility will be sent down to Permafix for grouting, from my understanding, and will be finally disposed of as low activity waste on the Hanford site in the integrated disposal facility, which was permitted for those types of waste streams.
So will Ecology ever consider putting grouted low activity waste from the tanks into
That's now.
on-site?
So long before I came here, when we had permitted the integrated disposal facility, there are specific provisions that don't allow grouted tank waste into the integrated disposal facility itself.
Will that ever change?
I think at this time, there is nothing planned for that to change. I think that would have some very robust conversation with the Department of Energy if that would ever be the case.
Then what allows that like evaporative effluent to be grouted and placed in the EDF?
So because it has gone through the high level vitrification treatment standard, so after it's gone through the melters, the low activity waste that we're talking about from the effluent management facility is the off gases that are being scrubbed. And that low activity waste is then being further treated at the EMF facility, at the ETF facility, and at Perma-Fix Northwest. At that point, it's not considered point of generation tank reach in a sense.
Understood.
All right, so I mentioned a little bit about this here. So we have been working with Department of Energy over the last 6 months or so on a permit modification to further expand the efficiencies that Department of Energy is trying to achieve here, right? And that has to do with the mixed waste byproduct routing from the effluent management facility. So that modification went through a public comment period, a public meeting, and had recently been issued by Department of Ecology via letter. There is a 30-day grace period associated with that. And I believe towards the end of June, pending any opposition to it, it will become effective. And as long as Department of Energy has all its other requirements in line with other agencies such as Department of Health, they should be able to move forward with their project to route some of the bottoms from the effluent management facility itself. All right, so we'll talk about some other obligations that Department of Energy has on the books. So we're going over to 200 West tank farms. So we spent a lot of time in 200 East talking about DF law and the activities happening over there. We are now switching gears and focusing our energy on 200 West. So we had talked about this, and I think Max had mentioned this. On July 1st, Department of Energy has to make a decision on where they're going to use their alternative treatment for the tank waste in 200 West, the grouting of that tank waste. Ecology awaits that decision because that will help us decide on what we need to do to get the permitting done so they can start their activities in 200 West. Right now, we're going through some permitting planning with Department of Energy on the pre-treatment system they're going to set up over there. Much like they have Tisker on the east side, they're going to have a pre-treatment system similar to that on the west side as well. And we're going through our permitting planning to kind of get that ready, go through the permitting, the public comments period that's associated with it, and allow energy to get to that place where they can start on the construction of the facility. All this stems from the holistic agreement, which was signed back in January of 2025. So ecology and energy are working diligently to move forward with the grouting activities that could occur in 200 West tank farms at this time. Moving on to some other progress that's been happening on the Hanford site. So we're encouraged by Department of Energy's transfer of cesium and strontium capsules from what's the pool wet storage that is currently in into dry storage into the cast that you see right there. I think the last time I checked, I think they're up to 3 casks being moved into dry storage at this point in time. So we're encouraged by the pace of the work that Heather and others at Department of Energy are doing to move this project forward to reduce the risk of the cesium and strontium capsules that is posed by keeping it in wet storage in the pools long term, right? So going to dry storage is much safer. So a little bit about public involvement that's coming up here. I believe Ricky had mentioned this. So on June 17th of this year, they're going to have the notice of intent public meeting in Richland. It will be a hybrid meeting. Ecology will be there as well to support in some capacity. And this is related to the work that's going to go on in 200 West, right? So right now, we don't have the ability to retreat in 200 West because the double shell tanks over there are full. We don't have the ability to treat any of that waste because the transfer lines that go from 200 west to 200 east are not operational at this point. So based off of the holistic agreement, we're moving forward with the notice of intent and the permitting that's going to be associated with this here in the near future over the next couple of years. Other public meetings that we have, so the Hanford site-wide permit is going out for public comment. We're aiming for June 29th. That will run for 120 days for October 2nd of 2026. We will have some informational meetings ahead of the public comment period starting. You'll get a little bit of a preview of that today. I'll try to cut it short as much as I can. But we do have that meeting coming up on June 10th for anybody that's interested in attending. And then finally, we have been working very hard to get the Hanford Air operating permit back out there. It went through renewal in a public comment period earlier this year. And we were working on response to comments. Because of the comments that we got, we made significant changes to the Hanford Air operating permit. We're going to put it out for another public comment period, tentatively scheduled for September of 2026. All right, so just a little bit of a preview for the Oregon Hanford Cleanup Board here on what's going to be in our June 10th slides. And I wanted to take this opportunity since we were here today to kind of run through that. So what is the Hanford site-wide permit? It's the culmination of 52 units or facilities on the Hanford site. So those are storage facilities, those are treatment facilities, disposal facilities, and waste sites that make up the 52 unit groups on the Hanford site. Our purpose for getting through the Red 9A public comment period for the renewal and getting this permit out there issued and effective is to protect human health and the environment, be responsive to public comments that we received from 2012 and what we'll receive this year as well, and having a consistent enforceable standard for the entire Hanford site for all the 52 facilities we have out there.
Yeah. So and that's the big thing, I think, especially like you said, enforcement and with everything happening, like with that, and especially mentioned the tri-party agreement. So what's like the biggest thing is the safety, because I mean, you saw what happened, you know, and like Lewis, but the big thing is what's the biggest thing or the safety that in college you might have any concerns on, you know, for that. I mean, Oregon, hopefully, you know, we can, you know, help, I don't know, maybe with that or that you guys in college, you know, especially working with energy, like in that collaborative, you know, environment.
Yeah, so I think, you know, what we're looking for right now is those public comments on all those facilities that we're going to be permitting. The purpose of the permit is to make sure the safe management of dangerous waste, or in this case, mixed waste, on the Hanford site, right? So the safe storage of waste, the safe treatment of waste at facilities like WTP, and the safe disposal of the waste in permitted landfills, right? Instead of, you know, what we have currently today, many unlined landfills on the Hanford site that have to be cleaned up as all right, so as I had mentioned, 120 days. Why this matters? So the permitted facilities on the Hanford site support the cleanup. You see that with direct feed low activity waste. You see that with ETF, the Central Waste Complex, the landfills that we're using on the Hanford site. All these facilities support cleanup on the Hanford site. And we want to make sure we have a complete, consistent, and enforceable permit. We want that one standard, and we want to be protective of human health and the environment. So a little bit about unit groups. We have operating unit groups. Direct feed low activity waste is the perfect example of that. We have closure unit groups. There are many unit groups on the Hanford site, facilities on the Hanford site that are no longer serving a purpose for the mission of cleanup, and they need to be clean closed. So we're gonna work with Department of Energy to establish closure plans for those units and have them go through the process of closing those units. And we do currently do that under the Rev 8C permit, the current permit that we have. A good example of that is the outside storage area A, which was a gravel location in the Central Waste Complex where there were unauthorized storage of dangerous waste containers on that site. As of today, all those containers have been moved off of that gravel site. Department of Energy is going through the process of sampling that site and trying to achieve clean closure of that one particular site. Many of the 52 unit groups are closure unit groups, so the permit itself facilitates cleanup of the Hanford site and closure of many of the facilities out there as well. We have post-closure unit groups that require further monitoring after closure has occurred. And then we have corrective action unit groups as well. So just a little bit of history on the Hanford site-wide permit. So it was first issued in 1994. The permittees are currently working under Rev 8C, as I had mentioned. And there are 22 waste sites and facility unit groups covered by Rev 8C right now. So I'll get a little bit into about why we have 22 unit groups versus 52 now. All right, so the Hanford site-wide permit renewal will add 30 unit groups. As I had mentioned, many of those are closure unit groups that require closure plans for clean closure. So we're gonna add these unit groups to the current Rev 9A permit to facilitate clean closure of those sites. And some of these are operating unit groups that are being added to the permit. Like I had mentioned, 200 West, we have to add a pretreatment facility. So we're adding another permitted facility to the site. We're making sure that those operations at that treatment facility operate in accordance with dangerous waste regulations. And we will work through the permitting of that among many other facilities on the Hanford site. Next slide, please. A little bit about the structure of the permit. So there are parts 1 and 2 general conditions that cover the whole Hanford site. You have unit-specific conditions for each one of those facilities on the Hanford sites under parts 3s and 4s. 5s and 6 as well. So depending on which type of unit group it is, whether it's operating, it's going to go through closure, post-closure, or corrective action. We have unit-specific conditions associated with each one of those as well. All right, so I alluded to this a little bit earlier. And we currently do have a publication out there. There is a link in here to it. The Rev 9A baseball cards. So those are out there right now for folks to look at. As we get closer to the public comment period, I really do encourage folks to go look at those baseball cards, look at each one of the facilities on the Hanford sites, and get a little bit familiar with each one of those facilities out there as well. We also have the website that's live right now, which has updates about the public meetings that are going to be happening, the lunch and learns that we're going to be intending to host every Wednesday for, I believe, what is it, 10 weeks?
Yeah, starting July 22nd.
July 22nd. The website's out there, the public hearings that we're going to have, and you know, an opportunity to ask any questions ahead of time about any of the information we have on the website right now, also leading up to the public comment period as well. So really encourage folks to go take a look at that as we approach the renewal and work towards a final status permit for the entire Hanford site. That's all I got.
Okay, thank you, Eddie. You anticipate this entire permit to be somewhere in the neighborhood of 20,000 pages? Is that what I understand?
Yes, so if you break that down for 52 unit groups, right? So it's about 300 pages per unit group, which is fairly reasonable for any permitted facility to have, you know, unit-specific conditions, all the addenda that are associated with it. So you have security addenda, you have contingency addenda for emergency response, preparedness, prevention. You have closure plans as well associated with each one of these unit groups. All the addenda that are associated with it come out to about, 300 pages per unit group on the Hanford side.
So this board obviously won't get too far down in the weeds, so to speak. That's Odo's job.
Yeah.
But what sort of feedback would be from this board would be helpful to ecology?
I don't want to specifically like solicit any specific type of feedback.
It's okay, you can.
We did a great job. And it's all good. We're ready to issue this thing. I think we really do want folks to take a look at this. There's been a big improvement from the permit that was put out in 2012 versus the permits that are being put out right now. And we're really looking for just public input on any concerns that you might have with any of the permitted facilities on the Hanford site, how we decided to move forward with, being consistent and make an enforceable permit for all of the facilities on the Hanford site. We're just really looking for any feedback that the public might have. This board is really in tune with the Hanford site, obviously. It has information specifically about unit groups that we would love to hear about any of those unit groups for the Hanford site, right, person.
I have one little tip. I think Stephanie, our program manager, shared this at one of the last Oregon Hanford board meetings. Correct me if I'm wrong, Eddie, but one suggestion she had was, I know it's a lot of unit groups, but if you commented a lot on like the waste treatment plant for the last couple of years, for example, a lot of the information is going to be the same from like the recent modifications we did. So I encourage you to focus on like new facilities you haven't commented on in the last couple of years that you're interested in. So maybe there's like a closing unit group that was added to the permit that you haven't commented on or seen and, for how long. So maybe one potential to help there again.
I'll add two pieces here. One, it is my goal to touch every one of those 20,000 pages and read the document. So if anyone on the board has a question about, the unit groups, I can do a book report out and then go from there, if we want to do that. Also, it's my understanding there might be some Oregon meetings and the OHCD might want to table at those meetings and just say, hey, we're here, we're watching it for you, we're doing this.
Okay. Senator Nash.
Yeah, one of the pictures you showed there of the large landscape, that landfill there. What will that be ultimately seeded over with or trees? What is the?
So dangerous waste landfills have a specific type of cover design that's required for them. I can't think of the cover design off the top of my head, but there is a specific type of cover design that's required for dangerous waste landfills, and that will be the one that some that'll be. Yes, I believe so.
When you reference August to the interim site tour, you'll be able to see something.
So it'll be covered with clay and geotextiles and soil, trying to keep plant to a minimum.
Yes.
But yeah, because you don't want the roots going into
No
it.
sagebrush.
Yeah, sure. Sure. I have a question.
Yes.
So I understand ecology is applying existing standards and does not control any federal definition or transportation rule. But my concern is practical on this, on the site-wide permit again, is expanding from 22 unit groups to 52. And grouting is obviously being emphasized as a major cost-saving tool. May 20th of this year, the Government Accountability Office report recommended Congress consider clarifying the Department of Energy's authority to manage some of Hanford tank waste as something other than high-level radioactive waste. If waste long managed as high-level radioactive waste is later managed as low-level radioactive waste, what guardrails does ecology have to ensure that that category change is based on actual risk reduction and long-term protectiveness and not primarily cost savings? You can kind of see where I'm going with this as transporting is different. And so if it's low-level waste, just like the question asked her, what are the standards? We're changing that. And first responders are believing that that's low-level waste, but it's been classified as high-level waste for not amount of years. What are the guardrails for that?
So one of the provisions of the holistic agreement required Department of Energy to notify us if they are going to use that reinterpretation. But at this time, we have not heard from Department of Energy that they intend to reinterpret high-level waste to low-activity waste. So there are some provisions within the holistic agreement that kind of kick off what comes next if that were to ever occur. We have found a workaround for that, right? So the GAO report talks about, why don't you just reclassify it?
Yeah.
And you can just, sort it all out because you just changed the classification of it. We do have a process, and it was proven out through the testbed initiative on how we can move forward with disposing of some of this tank waste through a treatability variance from EPA that's reviewed by them, the permitting that we have to do on the Hanford site, and the acceptance criteria at landfills around the country. The commercial landfill was utilized for the test bed initiative, for example, for Utah and Texas, right? So there are a number of ground barriers in place, hoops that Department of Energy would have to jump through, and ecology would certainly have their say each one of those steps essentially.
Jim, have a question.
Yeah, you were talking about the health of the folks and the environment. Getting back to the Trump administration a little bit, they've changed the degree to which you can have exposure, right? And
They're proposing to propose.
well, they're in charge as well.
Yeah.
But that's going to put you at loggerheads with EPA a little bit. So how do you work through that challenge? And I mean, does the ecology say, okay, we'll make nuclear workers or energy workers, try to breathe life back into nuclear energy, make them a bit of a sacrifice group, or do you? How do you battle EPA or administration on that?
Yeah, so related to the proposals related to LARA, for example, I think that's what you're talking about here.
Yeah.
So our partner agency, Washington Department of Health, is actually responsible for monitoring that. We have been in discussions with them about what they're seeing proposed, but haven't necessarily seen implemented at this point. So at least for right now, what we've heard from Department of Health is nothing has necessarily changed just yet, but currently monitored. Yeah.
So if I could opine on a couple of those last comments to address the one just previously out there, the Department of Energy has very rigorous standards for control of radiation dosages that are longstanding controls based on decades and decades of experience of exposure monitoring and health monitoring. And I'll just tell you that our limitations are extremely what's the word I'm searching for? We're very restricted in how much exposure we allow ourselves to allow employees to get, and that's not going to change. So the Alara thing is really about talking about siting new nuclear reactors, and it's a measure of, in an accident scenario from a nuclear reactor in somebody's neighborhood, what are the doses that might be received by the public, and how much money should be being spent to put on protective technology that would reduce those doses by so much. And that's where really that whole argument about getting rid of Alara is. It's inciting new reactor facilities and in determining the kind of safety controls and the amounts of money that new companies would have to spend to prevent potential exposures, in the event of an accident scenario. So that's kind of, it's not related to how we operate at site, and there's no intention of us, suddenly exposing our workers to more radiation. Regarding the transportation question, which is kind of where you directed it, is when a tank waste, no matter how we do it, whether it's by a weir process or whether it's by, this potential new idea of, alternative definition of high level waste, there are very rigorous rules that the Department of Transportation puts in place for transport of radioactive materials. And there are hundreds, to thousands of radioactive material shipments across the country, every month. And so those shipments would follow those very strict and very safe Department of Transportation guidelines. So in that case, when it comes to transport for disposal, DOT is the mechanism for defining what the limitations would be.
Okay, thank you, Ray. I think we need to close it up here. I want to do a quick poll of the group, break now or do EPA next? Any strong feelings one way or the other? Break now, I hear. Okay, 10 minutes.
But now I just can't see.
Sometimes I got the all.
Let's reconvene. Matt, are we ready to go on the slide deck?
We're working on it. It's, for some reason, the slide deck likes to reset to the first slide every time. I can start there. Anyway. We'll just have to get to slide number, 49. 49, that's where EPA is.
Okay, we're moving into the U.S. Environmental Protection Agency's presentation. Jeff, would you like to reintroduce yourself and take it away?
So I am Jeff Schramm. I am a remedial project manager for the Environmental Protection Agency on site. I think sometimes I was talking with Jeff before we sat down, and sometimes it's difficult to understand some of the lines where the two large regulations coexist at the same time, and that's RCRA space, the Resource Conservation and Recovery Act, which is what's been delegated to the state to manage, and CERCLA, also known as Superfund, and that's the cleanup side. So in your mind, for those of you who are new, when you think about RCRA and CERCLA, RCRA is the tank waste stuff. RCRA is anything time you hear permit, you're thinking RCRA. Cleanup, when you think records of decision, and then you'll hear a term like a pipeline of decisions, that's CERCLA. And so one of the things I want to talk about in my presentation, and I'm going to kind of surf through this a little bit, is what does EPA from a CERCLA standpoint do on the Hanford site? When you look at the TPA, it's clear we have an equal role with our partners, the Department of Energy and Ecology, but sometimes it's curious what we're doing. A question already? Haven't you got started?
What's the TPA?
Oh, the TPA is the tri-party agreement. It is a federal facility agreement. All Superfund federal sites have what's called an FFA, or a federal facility agreement. And our tri-party agreement is Hanford's version of the federal facility agreement that outlines what the roles are for the lead agency, the Department of Energy, our state regulator partners, and ourselves, that helps us guide through different processes on the site, and also work through any kind of dispute resolution. So it's an important document. It outlines what we need to do, how we do it, and who does it. And as I said, the Department of Energy is the lead cleanup energy for the Hanford site. From a federal standpoint, the EPA and from the federal standpoint, the EPA, and from a state standpoint, the Department of Ecology are tasked with overseeing the cleanup process and the RCRA process in the case for Department of Ecology, although EPA has we have a counterpart that does assist them in that process as well. What's interesting about it, as it relates to EPA, is when you talk to Ecology, I don't know how many folks from the CERCLA standpoint do you have in your office right now?
So most of them are within the cleanup section, so I'm thinking about 10 to 15 of those.
So there's 10 to 15 and probably what, 40 more from the permitting standpoint or larger, like that are doing, yeah. So they've got quite a large team. The Department of Energy, much like the EPA, in the last bit of about a year and a half, has lost a number of people. But there's still, I think there's still right around 200, maybe a little less than that right now on site. In our office, we have 4 project managers and 1 supervisor in our office. So we like to think of ourselves as a bit of a SEAL team. We need to be able to be mobile, and we need to understand what's going on throughout the whole site, and be able to help. And again, when I say what is EPA's role, our role is to shepherd through the Superfund process. So looking at identifying sites, doing remedial investigations, feasibility studies, proposed plans, kind of outlining this pipeline, the decision pipeline that leads to a record of decision. And a record of decision is what identifies the remedy and how we're going to approach cleanup on the site. So that was as quick as I could do it. So go ahead. Yeah, you can keep it, you're doing great. I'm not gonna follow the slides, but it gives you an idea here. I have, four of us that, and Laura Bulow is our supervisor, and then there's 4 RPMs or remedial project managers. We have responsibilities on the Hanford site, but we also have responsibilities outside of the Hanford site. So it's it's a big job. We talk a little bit about some of the folks that are in our regional chain. We'll go ahead, and Michelle Mullen right there at the bottom. Sorry, I said go ahead. Michelle Mullen, she's the counterpart that I talked about that works with ecology on RCRA related items. Go ahead.
What about Nick?
Nick is double duty. He's our attorney for our site, but he also is now the acting branch chief for all of Region 10. So he's busy. So we have a regional administrator now that was appointed by the president. Her name is Emma Pocon. Her deputy used to be, I work in Superfund and Emergency, the Superfund and Emergency Management Division of EPA in the region, and that's Cindy. Our director just got promoted to regional, deputy regional administrator. And Emma's chief of staff is Christina Carpenter. Some of you who have been around a while might know Dan Opalski. He is now the director of SENDI. So there's been a little bit of shifting around. We've all had to kind of move and be nimble and fluid in the process of the last year and a half. I won't go into this too much, but it just talks a little bit about our region. I want to talk about a couple of our accomplishments recently. Heather Dale talked about some stuff going on at K, so I won't go into a lot of that, but a lot of work has been done at K over the last few years in getting K East into interim safe storage, and now working through a lot of work to get it to work toward K West being remediated. And that's that tower or that stack that came down. There's only one more stack on site. Does anybody know what the one stack, other than folks, does anybody know what the other stack on site is right now? Not Tom?
B reactor?
The B reactor. The historic national monument. I always say, what is it? Park monument. I always get it mixed
That's on the
up.
river court.
It's a national park.
Park, it's a national park. Yeah, national, is it park? I always get it mixed up.
There's a stack in the Central Plateau as well,
Which one?
Central Waste Complex.
Yes,
Oh, I forgot about that
cell
one.
cooling.
Cambridge storage at the site.
Okay, so let me hit the rewind button on that for reactors. There's only one that's left, and that's at the B reactor. So it was an accomplishment. It's a big deal. There's a lot of visible work being done. But a lot of the work that we're doing on the river corridor now and on the Central Plateau that takes up a lot of my time is largely invisible. And that has a lot to do with groundwater and cleaning up groundwater underneath the Central Plateau, along the river. EPA's mission is identified as protecting human health and the environment. So that is our priority. So we're spending a lot of time trying to understand what's going on in groundwater and the contaminants that are in the ground right now, where it's going, and how do we remediate that. And we do that a couple of ways. We do that with our active remedies, and then pushing investigations to get remedies, and then push for cleanup. One of the things that we've done as well, and I think it's important to talk about this, and this is on the last slide, you don't have to go back, is that we've had an effort in really trying to have a more of a visible effort into completing what are called remedial action completion reports. And those reports identify a couple of things. It's a little bit of a misnomer. It doesn't mean that things are cleaned up and remediated and that the remedial action is completed. What it means is, like in the case for groundwater, all of the remedy components that are in place to then, because we have some remedies that are going in the hundreds of years, if not longer.
Yeah.
But all of the components for that remedy are in place according to that ROD and moving forward. So it's a check on, did we do what we needed to do, and are we ready to move forward? And those documents get put in the administrative record, and they're really interesting to understand kind of where we're at, what's been done, and that we're moving forward. So again, one of my jobs is to really push that pipeline and make sure that we're making good decisions. And for instance, along the river corridor, K and N, there's interim records of decision for both of them, but we've been working very hard to get final, it's not a term we like to use, it's just kind of confusing if you don't. Final records of decision, they encompass all of the remedies for both of those operable units. And then the river corridor will be complete, they'll all have complete records of decision. So that's a big deal that you're gonna hear about over the next couple of years as we push toward that. I do want to talk about the M100 milestone package. It actually, and it was brought, go ahead. Esteban.
Well, I think this is the biggest thing, and you know, when people ask me, especially like in other languages and other cultures, I think like kind of like what was mentioned before, is trying to explain the water, like you said, but you said you kind of do it on the down low. I don't know what else. So that's how I understood it. But you're trying to give like a basic 101 about like, hey, this is how we're getting the water, the groundwater, doing the work that it works the work. What's like the best, I mean, especially like the work that you're doing, especially when trying to explain it to
explain how we're cleaning up groundwater. It's a good decision, and I think it's something that we will this group and I and the Department of Energy will be talking more about that, because we're looking at some ways to look at groundwater in the Central Plateau right now. We need to make some decisions at a couple operable units there. So if your question is how do you explain cleanup of groundwater, that's a very difficult, it's a very difficult question to answer. But I will say this, and I'll try to make it as simple as I can right now as it relates to on the Central Plateau and on the river corridor. One of the technologies that we use is a pump and treat technology, where we pull water out of the ground, we run it through some filters, and we've heard terms like resin. We used to have a biofilter. You use granulated activated carbon, different filters to pull constituents out of that water, and then we inject it back into the ground at a gradient, pushing, for instance, away from the river in different ways, or controlling that groundwater, trying to keep the groundwater that's in place, it's not clean yet, stabilized and in place. I think that's the easiest way that I can explain that now. One of the other ways, one of the other remedies, and it sounds like, we're not doing anything, but it is it's an important remedy, and you see it often, and that's called monitored natural attenuation. And that means that we're keeping, as best we can, keeping contaminants in one place, and we're letting nature take its course and break down through chemistry and biology, break down those contaminants over long periods of time. So those are two very major remedies that we have in place, without getting into the weeds, which we can as we talk, not today, but in the future, we'll talk more about how we clean up groundwater and what that means. Did I answer your question?
A great way to talk and demonstrate the progress that's being done to people who don't know a lot about groundwater remediation is looking at the plume maps and how they've changed over time, especially on the river corridor. Phoenix is a website that P&L runs, and they actually have an animation of the plumes over time, so you can watch them shrink. So that's a pretty good tool. Words don't work.
Yeah, and it's tough because you're trying to words are very difficult when you're trying to explain to someone who doesn't understand it. And the modeling itself, where you're looking at those plume maps is actually quite different too, because when you're looking at those plumes, that's not exactly where the edge of those plumes are. It's a statistical model through averages that gives us an idea of where those plumes are. So, but we'll go into more detail as we go through, because we're going to be talking more over the next couple of years about groundwater.
Statistical.
I like to think that there was math. So am I wrong about that? Do they not?
There's statistics.
Yes, sir.
Yes, there is.
I'd like to think so.
You guys are gonna have to speak out.
So she was asking me if there was statistics involved in modeling on the site.
Of course.
And I believe there are, and Tom is backing me up on that.
And I'm still denying. I think I heard that though.
That they're just.
Plume mapping is both an art and a science.
Yeah.
But there is science involved.
And I think the most important thing about that, when you think about plume mapping and as an art and a science, is take it as that. Understand that it is that it's not a definite edge, that we definitely know something, that there is some you know, art to that as well. So I think that it's great to give a visual for groundwater in that regard and have that tangible way to look at it. But, you know, don't look at it as though this is exactly what we know and how we know it. It's complicated, but I don't want to make things work.
Jeff, since Tom brought it up, could you describe the kind of support you get from PNNL and?
Yeah. So, you know, the one
And
nice
what
thing,
PNNL stands for?
so the PNNL, it's a good question. PNNL is the Pacific Northwest National Laboratory. And just about all of the nuclear sites, I think all of them, have a laboratory that was built next to them that was doing research at the time that they were doing some of the work for the Manhattan Project. And so we have the Pacific Northwest National Lab. It brings in some of the smartest people in the country to come work on a myriad of issues, not just Hanford related stuff, but that gives us a cohort of people that will look at different technologies. And to give you an idea, I'll use one example of some support that and again, they're a contractor, but to DOE. One of the things that we're looking at right now are different resins. You keep hearing resins, and what I'd want you to think about with resin is Orbeez, right? Little balls and they, you know, there's very different kinds, but right, you know, I've seen a couple of them that look like little translucent balls.
That's not.
What's that? Go ahead. No, don't. Now, Michael,
Hey, Jeff, you're on a 5-minute clock.
thank you. Go. Okay, so water goes through it, stuff attaches to it, water's clean on the other end. Is that a good way?
Okay.
Perfect. So, now where was I going with that? What were we talking about? All right, I'll keep moving on to something else. PNNL, Pacific Northwest National Lab, they help us out a lot. Bright minds, they come up with, they write different papers and on different stuff on how to approach new technologies, and it's incredibly important and helps us not only get past what we know at the time, right? Some of our revenues are all that we know now, and they push us to discover new things. So I want to talk a little bit about the M24, the M100. Those milestones were signed and are complete. You're gonna be seeing that in the administrative record if we haven't seen it already, but they are done, which is really, you know, that's an important, we've worked on getting those completed or through understanding those and through completion for about 1.5 years. So that's a really big deal on things that we've been doing in the EPA office. The 324 building, the ROD amendment, so the amendment to the ROD to be able to move forward and change the revenue for the 324 is on the EPA side right now. And we are working to get signature and approval on that. And that should be coming, you know, this summer is what I've done.
For the uninitiated, could you describe why we care about 324?
Only if you give me 2 more minutes. Why do we care about the 324 building? The 324 building was used for research for, and you guys have had presentations on the 324, so I won't get into a lot of it. But there was a spill in the 324 building. I believe it was the late 80s. I think someone correct me if I'm wrong. That's very, very hot underneath the building. So the 324 building is very close to the city of Richland. It's very close to the river. People actually work in a building right next to it from PNNL, workers for PNNL. And getting that remediated and safe and taken care of is a high priority for the Department of Energy. It's a high priority for ecology and for the EPA. So in very short terms, that's the quickest way to put it.
How hot is very hot?
Oh gosh, somebody help me out. What is the
900 rem.
900 rem? I mean, it would kill you instantly.
Yeah, you got like a minute to be exposed.
And that building itself is protecting it, you know, the structure itself is protecting, but so this ROD and how we move forward and what we do with that is incredibly important.
Can you give us a preview about the amended ROD? What will it include?
I cannot. But I will say to be continued, but it has, again, this is my partner, Annie McCartney, it's her site and she's been working on it. But I can say, you know, that there is a remedy that's been chosen. I believe it, well, anyway, I don't want to talk too much about it because I'll end up just riffing and making a mistake.
Is there a milestone for that?
There will be a milestone once it is released. Yes.
Senator Matt.
Sure, thank you.
Yeah.
I just had a question. So this bill took place in the eighties, a high priority. Why is it getting taken care of now?
We just found it.
And you just found it?
Yeah, it was, what was it, just a couple of years ago, two years ago?
Yeah. Founded in the late nineties and then found out that it was bigger a couple years ago.
Yeah, what they did is they kind of took out some soil underneath the building and they were doing these bores to test kind of what was going on. And it's like, oh no, this is a lot harder than we thought. So we had to go back to the drawing board, figure out how we're gonna change the remedy. And that's why we're doing an amendment to the ROD, because we just found out that it was a much larger problem. That's a good question. Okay, so,
1 minute.
1 minute. If anybody has any questions about EPA.
Why does M100 matter?
M100 matters because what it allows us to do is look at the issues that we have in place, revisit those milestones annually and every 5 years, and really have good faith negotiations about where we're going, not speculating 100 years out as far as what we're going to do and having problems with funding and what does that even mean. So it really focuses our energy. It allows us to have clarity in making decisions, and it has us go back and recheck and reiterate and stay focused on what we're doing.
Okay.
This is really hard for me to talk.
Thank you, Jeff.
I love talking.
We appreciate it. We'll invite you back again.
Anytime. I'm your person on the board.
Okay, next on the agenda is the Oregon Department of Energy. Who's going to lead off?
Who's gonna lead them first? Matt, Tom, what? Let's talk true.
Let's talk true.
Well, yeah, let's talk true.
Let's talk true March first, then on the follow up.
So the week of August 10th, as we've talked about before, the road show for the resumption of the transuranic waste campaign, shipping campaign, which is going to start for sure in 2028, potential is for 2027. That week, starting on Monday, August 10th, the board and Odo staff will be traveling to Richland. That afternoon, Ecology is going to host us where an empty crew truck will be at their office. So we'll be able to see the truck, get some information from Carlsbad field office staff who will be there from WIP about the truck itself. You get to look at the true packs, answer some other questions. We'll have we've got hotel rooms, logistics. We've got hotel rooms booked that night because the next day there's going to be a Hanford site tour. And then on Wednesday, State of Washington gets to see the truck on that Tuesday. I'm asking Eddie, who's one of my colleagues on this planning committee, Tuesday. And then the OHCB and invited guests will be going with us to the Hanford site for a tour. Not the whole site, we'll be going to specific places. We've asked for the central waste complex where the true waste is being stored, part of that. We're still firming up the agenda for that trip. And then Wednesday, Tom, the HAB is going to see the truck Wednesday, correct, in the morning?
The HAB has scheduled events on the 12th and 13th. I'm not aware of what's happening and what times.
The truck then will move into Oregon and will go to Confederated Tribes Umatilla Indian Reservation at Pendleton for the next event for public officials to meet there, which will be, when I talk about the corridor, folks, I talk about the north end being Umatilla County and the southern end being in Ontario. That's the 200 plus miles of the route for the true shipments. So then it'll go from there. Max and I will be going to Pendleton, and then we will be following with folks from Carlsbad and also from Western Interstate Energy Board, from the WIPTAG, the Waste Isolation Pilot Plant Technical Advisory Group, down to Ontario for the final stop where we'll get other Oregon officials invited there. We'll be stopping in Ontario, and then it'll move on to Boise, and that'll end that week's activities. So that's what's going on with final 2026 activities for the resumption of the true shipping campaign. There's going to be more activities that are going to be occurring in 27 as we get ready for resumption in 28. And then I will be going, and so will Eddie, to the National Transportation Stakeholders Forum in 3 weeks down in Texas. We're part of the Western Regional Group, so we'll also take part in planning meetings along with our colleague James Hall from C2IRFR, who's also online, about August, and also interacting with DOE, talking about if there's going to be a start date, hard start date for 2027. There's also going to be, as part of the planning process, a tabletop exercise, which we believe C2IR will host, which will occur sometime in 2027 with members of the first responder community along the route. We'll go through simulated accident with a true truck. And then again, in 27, we'll also have probably one more opportunity for an empty truck to come through for other events where we'll, at that point in time, we'll coordinate with opening up opportunities for public engagement. We'll also be working with our elected officials to find out other communities we need to be talking to in Oregon along the way. That's on the resumption of the True campaign. And if I can segue into,
But first,
go ahead.
thumbnail description of what True is, where it comes from, how much it is, and how long this campaign, just a high level.
So the transuranic waste, which has been cleaned up on the site, there are several elements that represent True. It's stored in the Central Waste Complex for several years because there's been a 10-year hiatus on True shipping campaigns during that cleanup, because True can go to the waste isolation pilot plant in Carlsbad, New Mexico. That waste stream has a place that it can go, that deep geologic repository in New Mexico, the salt mine. So for the last 10 years during the hiatus, because they had an accident in 2014, Hanford has been cleaning up different sites, characterizing this True waste and storing it in Central Waste Complex. In the meantime, other sites have pushed their waste to WIP, and now it's Hanford's turn to get back in line to clean up there's going to be 6,000 shipments, so 2 a week for 10 years, just for True, down 84.
14 million cubic meters, I think, is the typical storage.
I would ask folks to refer to the project management plan, and I think Jay copied in that.
Yes.
Talks about the waste to be retrieved, what's in storage right now, what needs to be certified, transport and down some solution by offer some really good graphics and some information about
When we go on the site tour, you see the Central Waste Complex and you see the material, and you think of a 55-gallon drum. And majority of it's not liquid, it's not solid, it's basically tools that were contaminated during cleanup process. Tools and other equipment that are contained in these drums. They will go into a True Pack, an overpack. There's about 8 of them that go per True Pack. You're gonna see the True Packs when we go to the site in August. So when the Central Waste Complex essentially is starting to get de-inventoried, there's other sites that have been identified, other True waste that will have to get cleaned up, characterized, and moved into that stream, if that makes sense. So this is going to be a process going to take a while. And in the interim, as Ricky mentioned, we have the SIL campaign that is potentially going to start at the end of June. So those shipments, when we get advance notification that those are going to start this summer. So we're gonna have those on the road. Matt, what did we figure, 2 a week?
Just from, what?
Ricky said 3 a month.
Yeah, so those will start in those intermodal containers, and then we'll have the True at some point on that. And then do we want to mention the other potential True campaign? We want to wait the suspect?
Bring it on, Mark.
Suspect right here.
Yeah, I mean, it has been brought to folks' attention through Department of Energy's presentations. There is no clear timeline associated with that or actual plan to move any waste from Hanford to the Idaho National Lab at this time. I'm going to monitor that and work with Hanford on decisions that they don't make around what they're calling the suspect treatments.
So to provide some context, the suspect True is a potential that materials that were generated as part of the demolition of the plutonium finishing plant and plutonium recovery facility. It's rubble, building debris, would be taken to Idaho to be characterized and sorted, and then from there be disposed either in, I guess, Idaho or Cornell's Bend.
Yeah.
And with.
When we say Idaho, that's the Idaho National Lab, outside of